So welcome to Electronics Sector. So we are in PYQ of signal system of event semester 2024 and 25. So in this section we will see whole number of 6 mark questions. Okay. The first question is that y of n is equal to 3x of n plus 5. So we have to see whether the system is LTI system or not. Okay. There is a linear time invariant. Okay. So for checking the system is linear time invariant or not, we'll see first whether the system is linear or not. Then we'll see whether the system is time invariant or not. If the system is linear as well as time invariant, that is called the linear time invariant system. Okay. So let us check that. So first one is a linearity check. So in this case, if the sequences are input sequences are, let us say two input sequences are x1 of n and x2 of n, the corresponding outputs are y1 of n, which is the transformation of x1 of n. So that will be in place of x of n. So you have to put x1 of n. So that will be 3x1 of n plus 5. Similarly, y2 of n, that will be transformation of x2 of n. So in place of x of n, you have to write x2 of n. So that will be 3x2 n plus 5. Okay. Now the output to the system to the linear combination of x1 and x2. So that is your y3 of n. In this case, we can put in place of x of n a1 x1 plus a2 x2 n. Okay. So that will be 3 into a1 x1 plus a2 x2 of n. Okay. So that will be 3 a1 x1 plus 3 a2 x2 n plus 5. Okay. So in this case, there are two things are there. Okay. So if a1 y1 of n plus a2 y2 of n is equal to, that is y3 of n, then the system is called the linear system. Y3 of n equal to this one. This one is your y3 of n. Okay, so that we have put. So now what is a1 y1 of n? So a1 means this is y1 of n. So 3 x1 plus 5. So in place of this y of y1 of n, you have to multiply a1. So that will be 3 a1 x1 of n plus 5 similar to plus a2. So a2 3 a2 x2 of n plus 5. Okay. So now it will be 3 a1 x1 of n plus 3 a2 x2 of n plus 10. You can see plus 10 there. There is a plus 10. So in this case, you can see y3 of n, which is equal to 3a1 x1 n plus 3 x2 a2 x2 n plus 5. So these two equations are not equal. So that is the why the system is non-linear. Okay, so you can see this will equal to plus 10, it is plus 5. So that will be not equal. Okay, so let us check that once again. So the linear combination of two outputs that will yields. So that yields a1 y1 of n plus a2 y2 of n. So that will be plus 10. You can see. So that is why the equation 1 and equation 2 are not identical. Therefore, the superposition theorem is not satisfied. The system is non-linear systems. Okay. So in this case, there is not LTI because it is not linear. Okay. So let us check also time invariant check. So in this case, the input is delayed by the k samples and applied to the system. The output will be, so what is the our input? So y of n equal to, so y of 1 n equal to 3x of n plus 5. Okay. So in this case, the input is delayed by k sample. That means you have to in place of x means x of n, you have to put x of n minus k. Okay. So that will be 3 x of n minus k plus 5. So you have to only input that will be delayed by that means k. Okay, that input will be delayed by means that will be 3n minus k. Okay, so that will be 3x of n minus k plus 5. Okay, second thing is that you have to check if we delay the output by k units of time. So you can it is the you can see what is the our means equation y of n is again equal to 3x of n plus 5. So in this case, the output is relay means this n will be replaced by n minus k. Okay, the n will be replaced by n minus k. Okay, so these two are equal. You can see. So y of n comma k is y of n minus k. So that is why the system is time invariant, but the system is not linear. That is why the given system is not means linear time invariant or linear time variant system. Okay, because it is not linear. Okay, but it is a time invariant, but it is not linear. Okay. So it is neither LTV nor LTV. Sorry, LTI. This is linear time invariant means that is not LTI systems. Okay. So in this case, you have to check the system is time invariant first you find out what is y of n comma k. So y of n comma k is found out by uh, simply delay the input by k units of time. In this case, you can replace small n by n minus k. Okay. If both are equal, the system is time invariant. If both are not equal, the system is time variant. Okay. So this is your first 6 mark questions. Second is your partition energy signal and power signal explained with examples. Okay. So a signal is said to be energy signal if the energy is finite and the average power is always zero. In this case, so we can see this if the average power is equal to zero and the energy is finite. Okay, then the signal is called the energy signal. Okay. This is called the energy signal if the energy is finite and power is equal to zero. Okay. So in this case, for a discrete time signal that is x of n, the power energy can be uh, found out by this equation. Okay. So x of n is a discrete time signal. Similarly, for continuous time signal, the energy E of a continuous time signal is this one. Okay. So here xt equal to a continuous time signal. Okay. So let us see some examples. So example is this one. This is a discrete time energy signal. Okay. Signal, this is a continuous time energy signal. So you have to explain with examples. Okay. So as is energy signal is that in which the energy is finite and average power equal to zero. Okay. And this is the equation to find out the energy of a signal. These are the examples. Okay. So this is the energy signal. Next one is power signal. If a signal is set to a power signal, its average power is finite. In this case, the energy equal to infinity. Okay. So the energy is infinity and power is finite. Then it is called the power signal. Okay. This is the power signal. Okay. In this case also there are formulas. So finding out the power. Okay. So in this case, for discrete time signal, the average power of a discrete time signal x of n is defined as this equations. Okay. For x of n is the means discrete time signal. Similarly, for the continuous time signal, this is the average power, where x of t is the continuous time signal. So let us see some examples. So the x of n equal to e of n. This is a power signal. So e to the power of j theta, that is will be our power signal. Similarly, sin theta, that would be a power signal. Similarly, this is a continuous time signal, which x of t equal to cos t. This is also a power signal. Okay. So in this all the cases you can see, in all the cases there is a power is finite. Okay. The average power is finite and energy equal to infinity. Okay. That is why these signals are called the power signals. Okay. And this is our second 6 mark questions. Next one is a state and prove the multiplication properties of continuous time Fourier transform. Okay. So the if x1 of t, the Fourier transform is x1 of j omega. x2 of t, the Fourier transform is x2 of j omega. Then x1 of t into x2 of t. This is a multiplication of two signals in time domain. That will be the convolution of these two signals. The Fourier transform will be the convolution of two signals in the frequency domain. Okay. So let us prove that. So this is the Fourier transform. So that is the f of x of 1 plus x into x of 2, 1 upon 2 pi. So that is the minus infinity plus infinity x1 of j omega star of this will prove. Okay, x2 of j omega. That will be proved. We will prove this one. Okay. So next one is your, so let y of t equal to x1 of t and x2 of t. This is the multiplication in time domain. So here the Fourier transform is y of omega, that will be e to the power means minus infinity plus infinity x1 of t into x2 of t, that will be e to the minus j omega t dt. Okay. Or you can write here j omega also. Okay. So the inverse Fourier transform is your x2 of t equal to 1 upon 2 pi. This is the inverse Fourier transform. It will be minus infinity plus infinity x2 of lambda into e to the power of j lambda t. This is your inverse Fourier transform. Okay. So let us substitute this into this equation. Okay. Suppose this is our equation 1. Okay, and this is our equation 2. So substitute the expression for x2 in equation 1. Okay. So this will be our equation. So that will be x1 of t into, this is the substitute, we have done the substitution of x2. Okay. So we have e to the j omega t dt. Okay. Now 1 upon 2 pi take outside. This is our, you can means e to the power j t you can take common. Okay. So that will be the thing. Then it is my integration of minus infinity plus x1 of t e to the power j equal to x1 of omega minus lambda. So let us put over here. So that will be x1 of omega minus lambda d lambda. So this is our convolution. So x1 of omega into x2 of omega. Okay. So this is our called the multiplication properties of continuous time Fourier transform. Okay. So next measure, so we'll see this last question, that is the find the cross correlation of the two sequences. The two sequences are given. You have to find out the cross correlation. Means the cross correlation means there are two different sequences are there. So R of x y, okay, of L. So let us see that. Okay. So in this case, x1, x of n is this one, y of n is this one. Okay. So that is the formula. So R of x y L, it will be x n star of y of minus n. So this is the formula for the cross correlation. So x of n, y of n minus n. Okay. So now this is x of n in the means graphical representation of x of n. Then it is a y of n. Okay. So let us see check the what is the starting point of our cross correlation, the ending point of our cross correlations. Okay. So this is y of minus n. So y of n minus n can be found out as you can see. This is our y of n. So this is the starting point. So y of minus n means y of minus n. That will be our means 1 minus 2 1 the same, that will be, but the starting point is one means this signal started this one. So signal started minus this signal started minus 2 minus 1 and minus 0. Okay. So this is our y of minus n. Okay. So this is the n values. Okay. Similarly, x of n. So what is the starting point? Starting point is your 0. Starting point is your 0. And what is the ending point? So 0, 1, 2, 3, 4. So ending point is 4. Okay. So ending point is 4. So what will be the starting point and ending point of r of xy? So you can see this will start at minus t. The starting point is your starting point. Okay, at minus t. This rx1. Then ending point is your 4. Okay. So minus 2 and 4. Minus 2 is the starting point. So you can take L is from minus 2 to 4. Okay, that is the thing. Okay. So you can take the highest between these two. You can see the highest is your here 4. In this case also, in the means left hand side on negative axis, the highest is at minus 2. If we compare between these two signals. Okay. That is why you can take this lowest point and the highest point. Okay. So starting point is your lowest point, that is minus 2, and the highest point is at 4. Between these two signals you can compare. Between x of n and y of minus n, what is the lowest point? The lowest point is minus 2. Lowest point minus 2 of this minus 2 means y of minus n, the lowest point is minus 2. Okay, that is why the lowest point is minus 2. You can compare these two. Okay, here the lowest point is, what is the lowest point here? Lowest point is 0. Okay, so that is why you can take the lowest between this x1 of n and x of n and y of minus n. That is the minus 2. Okay. Similarly, you can take the highest point of x of n and y of minus n. Here the highest point is your 0 in case of y of minus 1, and x of n the highest point is 4. So that is why you can take highest between these two. Okay, that is why it is 4. So the y of rxl, that will starting point is minus 2 and ending point is 4. So we have minus 2, minus 1, 0. Okay, then 1, 2, 3, 4. So as many as did L, these are the L. So we have to find out, means for L value, these are the L values. So we have to find out for these L values what is our R, X, Y, L. Okay. So let us start that. So lowest point is minus 2 and highest point is 4. So this is the formula. So first you can check whether L equal to, for L equal to 0. So you can put here L equal to 0. So it will be x of n will be multiplied with a y of n. This is your x of n. This is your y of n. So you can multiply between the common point. So 0 here is minus 2 and 0 it is 1. So minus 2 into 1. Okay. So minus 2 into 1. Similarly, that will be at 1 it is minus 2, at 1 it is 6. So 6 into minus 2. Okay. Similarly, as 2 it is 7, 2 is 1. So it is 7 into 1. So that is the answer. So minus 2 minus 12 plus 7. Okay. So that will be minus 7. So minus 2 minus 7 plus 7, that will be minus 7. Okay. Similarly, we can find out for L value equal to 1. For L equal to 1, so this is the formula. So R x y n 1. So L value is here 1. Okay. So in this case, y of n minus 1 is obtained by shifting y of n towards right by 1 unit of time. So this is our y of n. it will you can shift this towards the right. Okay, you can shift this towards the right by 1 unit of time. So this place will be -1, this will be 0, this will be 1. Okay, so this is our towards the right. Okay, sorry, towards the right means this will be shifted towards the means this is 1. Okay, 1, 2 and 3. Okay, towards right we can shift. So 1, 2 and 3. Okay, next it will be multiplied with x of n. That will be multiplied with x of n. So this is your x of n. So we can multiply this. So that will be common points are, you can see 1. So 1 means that is 6, it is 1. 6 into 1, then 2 it is -2, so 2 it is 7. So 7 into -2, so 3 it is 1, so 1 into 1. So 6 means that 6 into 1, that will be 6, then -2 into 7, that is -14, then 3 it is 1, 3 it is 1, so plus 1, that will be 7. Okay. Next is your y of n minus 2, we can find out for L equal to 2, that will be shifted the this one towards the right. Okay, so that will be 2, 3 and 4. Okay, so 2, 3 and 4. We are shifting the in the time axis. Okay, so that will be multiplied with x of n, that will be multiplied. So you can see this 2, so it is 1, so 2 into 7, so 7, that will be 7. So at 3 it is -2, at 3 it is 1, so that will be -2. At 4 it is 1, at 4 it is 9, so plus 9, that will be 14. Okay. So next is L equal to 3. So this is our formula. So for L equal to 3, so y of n minus 3 is obtained by shifting y of -2 towards the right by 1 unit time. So this is our y of n minus 2. So that will be 3, 4 and 5. So 3, 4 and 5. So that will be multiplied with this x of n. So that is, at 3 it is 1, at 3 it is 1. So 1 into 1, you can see 1 into 1. Similarly, at 4 it is -2, at 4 it is 9. So 9 into -2, it will be -18, it will be -17. Okay. Next is for L equal to 4. So that will be y of n minus 4, that will be obtained by shifting y of n minus 3 towards the right by 1 unit of time. So this is your y of n minus 3. So that will be shifted towards the right. So this is 4, 6 and 4, 5 and 6. That will be multiplied with x of n. So here you can see at 4 it is 1. So at 4 it is 9. So it will be 9. Okay. So there is no value at 5, 6, so something like that. So that these values are 0. So that is why you can take only the common points. Okay. That is 1. 1, at 4 it is 1, at 4 it is 9. So we have found out all the values of in the positive direction. So let us see some negative values, means it -2 and -1. Okay. So similarly -1, this is our formula for finding out the r of xy at -1. So it will be obtained by shifting a y of n towards the left. You can see 1 into 10. So that will be shifted towards the left. Okay. So this will be shifted towards the left. Okay. So that will be 1. Means that will be this 1, then 0, then -1. Okay. So you can see -1, 0 and 1. Only you can shift the time axis. Amplitude remains same. Okay. So this is y of n plus 1, that will be multiplied with x of n. Okay. This is our x of n, that will be multiplied. So let us multiply that. So at -1 it is 1, so there is no -1 values. So at 0 it is -2, at 0 it is -2. -2 into -2 it will be 4. Okay. It is 4. At 1 it is 1, at 1 it is 6. So 6 into 1, it will be 10. Okay. So this is your r of xy -1. The last one is your y of at n equal to -2. So this is our y of n plus 2. So y of n plus 2 is obtained by shifting y of n plus 1 towards the left by 1 unit in time. Okay. So this is our y of n plus 1, that will be shifted towards the left by 1 unit of time. So -2, -1 and 0. It will be multiplied with x of n. So let us check that. So what is multiplied? We can see at -2 there is no values, -1 there is no value. So only have 0 at 1. So it is 0, it is -2. It will be -2. Okay. So we have got all the values. So this is our result. Okay. So let us conclude this by seeing that whether our answer is correct or not by the some checking. Okay. So for tabulation method, for checking, we can see this is our result. So we can check. So this is not x of n. This is our r of xyl. Okay. This is our r of xyl. Okay. So you can see this is our y of -1. So please write in this way, and this is our x of 1. So just you can see multiply this. So -2 it will multiply with all these three. So -2 that will be -2, 4 and -2. Okay. Similarly, this 6 will multiply with all this. So 6 -12 and 6. Then 7 it will be 7 -14 7. Then 1 -2 -1. Then 1. Then 9 -18 plus 9. Okay. Let us add this diagonally. So first one is in -2. So minus 2 is there. So then add this 2, 6 plus 10 is 4, that will be 10. Then add this, so that will be minus 7. Then it will be 6 plus 7 minus 1, that will be minus 7. That will be 9, 9 plus 1, 16 minus 2, so that will be added. That will be 14. Then 8 minus 18 plus n 1, that will be 17. Then it is 9. Okay. So this is our assumption, means our result is correct. Okay. So this method is useful for checking. Okay, whether our result is um, means right or wrong. Okay. So we have seen four number of 6 mark questions. So let us conclude this. So these are the references. So if we have any doubt, you can ask me in the comment section. Thank you all. In the next section, we'll see next four number of questions. So have a nice day. Thank you all. Okay.